Today we're looking at the Physics AS Unit 2 paper from CCEA, the 2016 one from June, and it's Waves, Photons and Medical. Question 7. X-rays are commonly used as an imaging technique in medicine, and X-rays are produced by bombarding a metal target with electrons of suitable energy. There are two distinct methods. Describe the two methods. Okay, so we've got two things here. You've got, first of all, your braking radiation. Now that's what happens when you get electrons slowing down. They emit high energy photons, and that's what we call braking radiation. And that produces the whale hump shape of the X-rays. So we have this idea of them being decelerated by their collisions with the target, and that causes the emission of a wide range of X-ray energies. Now, as well as that, you've got this other thing that produces the spikes, and that we call that the characteristic part of the X-rays, and it's produced by electrons being knocked out from the atoms. So incoming electrons knock out inner shell electron from the target atom. A specific X-ray is emitted when an outer electron jumps to fill the vacancy, and this is because there's a specific energy jump that will then produce these exact frequencies of the X-rays, and that's really what's going on there. Part B then, CT scanning is a powerful diagnostic tool that uses X-rays. What does CT stand for? Well, CT is just straight from your notes, that's computed tomography. Now, part 2, both CT scanner and the conventional X-ray machine require the use of an X-ray beam and a detector. Outline the difference in the procedure employed with the beam and detector when each technique is used. So with conventional X-ray, you've got like a fixed beam and a fixed detector. Neither of them are moving, so it's a straightforward shadow photograph. With the CT, both of them are in motion around the patient. So because you've got them doing that, then it's a different kind of process. So you've got a beam that's rotating around the patient. You've got a screen at the other side that's rotating around the patient. And that's how the CT system works. Part 3, state one disadvantage of using a CT scanner instead of a conventional X-ray machine when used for producing images of patients. Well, obviously by the CT process, the beam is going to be on for longer, and so that's going to be producing a longer amount of X-rays, so you're going to give a higher dose to the patient. And CT would also be more expensive because it's a much more complex machine than a straightforward X-ray table. Question 8. Photoelectric emission can occur when metal surfaces are illuminated by electromagnetic radiation. Under certain conditions, photoelectrons are emitted from the metallic surface. State the conditions under which photoelectric emission can occur. So you have to have the photons absorbed by the metal atoms to excite the electrons and give them energy, and the photons must have enough energy to overcome the work function to give the electron enough energy to escape from the atom. Part B, the minimum frequency of radiation for which photoelectric emission occurs when a platinum surface is illuminated is 2.5 times 10 to the 15 Hz. Calculate the work function of platinum surface in electron volts. So first of all, we take this F0 value, this threshold frequency, and we realise that phi, the work function, is going to be H times F0. So we just calculate that, multiply our H value by our frequency, and we get that in joules to be 1.65 times 10 to the minus 18 joules. But they don't want it in joules, so we need to divide by the electron charge in order to get it in EV, and that gives us a value of 10.36 when we do that through the calculator. The frequency of illuminating radiation is kept constant at 2.5 times 10 to the 15 Hz, but the intensity of the radiation is increased. So we're keeping the frequency constant. That means each photon has the same energy, but we're increasing the intensity, but that means there's more of the photons. So what effect this would have then on the kinetic energy of the emitted photoelectrons? Well, nothing. The kinetic energy would stay the same. If you don't change the frequency, there's no spare energy left over other than what you already had. So what effect would this have on the photoelectrons? Well, the increase in intensity will produce more photons, and more photons coming in will produce more photoelectrons. So we would expect the number of them to increase, like the photocurrent, if you were measuring it in a little circuit. So we're sending in more photons, we're going to get out more photoelectrons. But because we haven't changed the frequency, the spare energy is going to be the same. So the kinetic energy left over to become the energy of the photoelectrons as they leave, that's what's left over when you take away the work function from the photon energy. And so the leftover kinetic energy hasn't increased because basically the photon energy coming in hasn't increased. There may be more of them and they can produce more photocurrent, but the kinetic energy of the photoelectrons is fixed by that frequency of photons that are coming in. So a brighter light with the same frequency can't provide any more kinetic energy for the photoelectrons, it can just provide more of them. And that's that then. Hope that's helped. Thanks for watching.